Hi, what's up, guys? Today let's look at the Lintcode problem number 111, climbing stairs. Problem description: You're climbing a staircase. It takes n steps to reach to the top. So each time you can either climb one or two steps. So question is that how many distinct ways that you can climb to the top? For example, um, n equals to 3. That means we have a stair. We have 3 steps of staircases, and there are 3 solutions. We can, jump 3 times. Each time we jump 1 step, or we can jump 2 times. First time we jump 2 steps. Second time we jump one, and vice versa. So eventually we have 3 solutions, 3 distinct ways. So how to do this problem? How to resolve it? Our solution, our algorithm will be DP, dynamic programming. Why is that? Because still we found some keywords. The keywords is that how many distinct ways. Again, when you say the problems, ask us to figure out how many possible solutions, but not require us to give the specific solution. So we're safe. I mean, 99% that we have to use the dynamic programming. So let's see how to do it. Like I mentioned in my previous tutorials, to use DP to resolve problems, then first we have to, complete 4 tasks. The first one is definition. Um, we're gonna have to define a DP array, so we need to give a definition. In this case, we define DPI, which is use one dimension. DPI. The definition is that usually the definition is very close to the problem that we need to resolve. Because in the problem, we need to resolve how many ways to jump to the top. So DPI, our definition is how many distinct ways to jump to step I. There, note that the step actually is from from 1 to I. Okay, so what is our answer? Answer will be DPN because we need to reach to the top. And the top stair is the N, so answer is DPN. And question number 3 is that what is the state transfer equation? We need to find a relationship between DPI and its previous states. So in our case, if you want to reach to DPI, staircase I, you can possibly jump from I minus 1, or you can possibly jump from stair I minus 2. Why is that? Because each time you can either climb 1 or 2 steps. So the total distinct ways that you can jump to I minus 1 plus the total distinct ways that you can jump from I minus 2 is the total distinct ways that you can jump to DPI. So this is the state transfer equation. That is very straightforward, and we're so happy that we figured it out. And last step will be initialization. In our case, you see, we use the 2 states in our DP state transfer equation. That means we have to give out 2 initialization values. So we need to give the DP0 and DP1. DP1 is very easy to understand, right? We just jump to a staircase 1. It's very simple. We just we only have one solution to do that. But this DP0 is actually a little bit tricky. Like I mentioned, the staircase, the stair actually starts from 1. So DP0 means what? DP0 means we don't jump. We don't jump. So in this case, actually, you don't jump is also a solution. So that is 1. I know it sounds a little bit tricky, but you realize that you can only just initialize DP0 to be 1, then your DPI, this state transfer equation, will be valid. So, yeah, this is the 4 questions we have answered. So let's look at the coding, how we do it. Climb stairs, we take the argument n. First, we need to do some checking. If the n is 0, that means there is no staircases. So we just return 0. We don't have to do anything. If there are one staircases or two staircases, we just return n. Why is that? Because if the n equals to 1, we can only just have one, distinct jump ways. If there are two staircases, we just have two distinct ways to jump. So we just return 2. So that's why combined together, we just return n. All right, this is special cases. So once this is done, okay, we're going to just use the DP, dynamic programming. We do the initialization like we talked about. We initialize DP0 to be 1, DP1 to be 1. All right, second, we're going to just use a for loop to calculate all of the states in that DP array. Eventually, we have to calculate the whole DP. We just use the for loop to do that. The yearly for loop is a good way to do that. If you have a two-dimensional array, so you probably need to have two nested for loops. If you have three-dimensional array, you may need to do three nested for loops. Yeah. In our case, it's just the one-dimensional. And we put our state transfer equation here, and our answer will be dpn. So yeah, that's it. So let's see how it works. Awesome. So see, it's totally 100% right. All right, thanks. That's today's algorithm. I see you in next video tutorials. Thanks. Bye-bye.